Right, today's show is on organic chemistry and really just looking at the fundamentals of organic chemistry as well as the physical properties. So there might be a little bit of physical properties and maybe a little bit on organic reactions, but the focus today is on organic chemistry. And we got a learner who sent in a question, and I'd like to go to the learner now. Great, thank you. So let us have a look at the question that was sent in. All right, so we've got our compounds, and these organic compounds is a general format for this kind of question is where they will give you 5 or 6 organic compounds. In this question here, we have actually 5 organic compounds, and what I would like you to do is when you get your question like this is to look at those organic compounds and to identify as best as you can the functional groups and possibly the homologous series to which they belong to. So let us have a look at the table again. All right, so compound A, I notice I've got 4 carbons in a straight chain, and I see over here, let me just select my pen. I'm going to try yellow, and I see over here I've got a hydroxyl group. All right, so that is representative then of a alcohol. So make a note of that on your question paper. So when you get into working out the question, that you've already got a little bit of background as to each of the compounds. So let us write in. This is going to represent an alcohol. Looking at number B, or organic compound B, I see it's got a C double bond OH, and it ends with that C double bond H. Now this C double bond O is known as a carbonyl group, and there's a hydrogen and it's at the end of the structure. Now this could be at the end or at the start of the compound, and this is going to be my aldehyde. So that is representative of the homologous series aldehydes. Looking at compound C, once again I see that there is a OL, and on the first carbon there's this OL, it says, and that also once again represents my alcohol. Looking at compound D, butane 2-one, this is telling me here that this belongs to the homologous series of ketones. And then the last one, this I notice is also an alcohol. So I see on this carbon there's an alcohol, and I seem to have numerous branches on the parent chain, but this is once again also going to be an alcohol. So before you even identify or try and answer the questions, identify those organic compounds. Sorry, I don't know what I did here. Don't know what I touched. Sorry about that. Go back to the question. So before you actually get onto answering the questions, identify each of those compounds just to simplify it and just to direct your thoughts. So when you get to answering the question, that you don't struggle too much or get too confused. I think we just get confused at times because some of these functional groups are very similar to one another. So identify them first and then go into the question. All right, so let's look at the first question. All right, it says write down the letter that represents each of the following. A tertiary alcohol. Okay, so first of all, we need to have a look at what is a tertiary alcohol. So a tertiary alcohol, if I have a look at my compounds here, this is going to be a tertiary alcohol. Why? So let me just erase this now. Actually, just start again. So we know that's the alcohol. All right, so if I look at this carbon here, this OH that is attached to it has got 1, 2, 3 other carbons around it. So 3, another name for 3 would be tri or tertiary. All right, so that carbon where the OH is connected has 3 other carbons connected to the carbon with the hydroxyl group. So that is going to be my tertiary alcohol. So the first answer is going to be A. All right, so tertiary alcohol is going to be represented by compound A. An aldehyde, there we go. So that is easy. So we've got aldehyde was my compound B, so we've already got that answer, which is nice and easy, so we can just write down B. All right, they want to know a ketone. I think we also identified a ketone. Oh, there we go. So now it's easy. There's my ketone, so it is going to be D. And there we go. Right. The last question says a functional isomer of compound B. All right, so let's have a look. What is compound B? Compound B is my aldehyde. Now we need to have a look at how many carbons we have. 1, 2, 3, 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So if I have a look at that structure, B has got a formula of C4H8O. Now, a functional isomer is something with the same molecular formula. So it's going to have whichever other compound, same molecular formula. So it's going to have 4 carbons. So let us have a look on our table here. Compound A has got 1, 2, 3, 4, 5 carbons, so it can't be compound A. Compound B is the one they're referring to. Compound C has 4 carbons and compound D has 4 carbons. So now it could be either compound C or compound D. But we need to have 8 hydrogens. All right, so how many hydrogens does butanol have? So if we draw out butanol, 1, 2, 3, 4, and we go and put in all the bonds around it, and it's butane 1-ol, so there we go. Now you go count those hydrogens, and how many hydrogens are we going to find? So let us have a look. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 hydrogens. So it definitely can't be that compound. So remember, an isomer has the same molecular formula, the same number of carbons, the same number of hydrogens, and will have the same number of oxygens as well in this instance. Okay? So therefore, it can't be compound C. So let us have a look at compound D. So if I draw out compound D, it's butane 2-one. So butane 2-one, there are 4 carbons. On the second carbon, there's my carbonyl group and my hydrogens. Always count your bonds. So it's 1, 2, 3, 4. So don't put in too many bonds or hydrogens. So always count. Maximum of 4 bonds. So now I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 4 carbons, yes. I've got 8 hydrogens, yes. And I've got 1 oxygen, yes. So which is going to be a functional isomer of compound B? It's going to be compound D. All right. It's a lot of work actually for 1 mark. All right, so we just need to remember that functional isomers will have the same general formula, but their functional group is going to be different. Okay, let us look at the next question. It says, write down the IUPAC name of compound B. So looking at compound B, I've got 1. So always count your longest chain. So there's 1, 2, 3, 4. And in fact, I've done that wrong. Why have I done that wrong? Because your functional group for these ones, this is going to be carbon number 1. That will be carbon 2, that will be carbon 3, and that will be carbon 4. So remember, with the aldehyde, where that aldehyde group is, will be carbon number 1. So I've got 1, 2, 3, 4 carbons. So 4 carbons. The front part of the name is butane. And what is this? It's an aldehyde, so it's butanol. And we don't give a position because that functional group is always on position number 1. All right, so compound B is going to be called butanol. And just watch your handwriting. All right, it must be AL. Don't let it look like an O, otherwise it's going to be incorrect. All right, compound E. We need the IUPAC name of compound E. Now, compound E is quite a long structure, and it's quite a big structure. Now, something to keep in mind that we will always count the shortest distance to the side chains, or in this instance, to a halogen, or here, a hydroxyl group. All right, now the hydroxyl group will take preference over anything else in this organic compound. So we are going to start numbering it from the right-hand side, always the shortest distance to that OH group. So let us have a look. And then don't forget to count the longest chain. So don't just assume it's going to be in a straight chain. Look if it's going down, look at the up, always count to make sure you've identified the longest chain. So let us have a look. All right, so this is going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Yes, carbon 6. Now I see on carbon 5 it goes up, so if it goes 5, 6, 7, so it could be heptanal. If I go one further, that's 6, and if I go up, that's 7. So that's still looks as though if I go this way now, so if I go here and down, it looks as though that might be my longest chain. So 1, 2, 3, 4, 5, 6, 7, 8. So if I went in the straight chain, that would just be heptanal. So it looks as though my 8 carbon chain is going to be the longest. So in that case, we know we're going to have octanol. There's my eraser again. All right, so we're going to have, sorry, let's select a pen again. So it's octanol or octanol. But now we need to split it. We need to tell them that on carbon number 3 is the OH group. So it's octan 3-ol. So it's octanol, but on the third carbon, there is my OH group. So on the third carbon, there is my hydroxyl group. All right, and the longest chain has 8 carbons. Now we've got to look to the branches. So I see here's a branch over here. And there appears to be a branch here that I haven't named, and this one over here. So I notice that on the 6th carbon, I have a methyl group and another methyl group. So that is going to give me 6,6 dimethyl. On carbon number 5, I have 2 carbons in a straight chain over there, and that's going to be ethyl. Now remember, when you are writing down those branches, we always do it alphabetically. All right, so we have to do it alphabetically. So if I'm looking at a methyl, it starts with an M. If I'm looking at ethyl, it starts with an E. So I will always write ethyl first. Even though it's dimethyl, you ignore the D for the dimethyl. It's about the M for methyl and the E for ethyl. So it's a little bit confusing. So you just stick with M and E. So E comes first, so we're going to put that first as my side chain, and then the dimethyl. Okay, so on carbon number 5, we had an ethyl, and okay, I'm running out of space here, so let's just give myself more space. All right, so on carbon number 5, we had an ethyl. You have to put the hyphen in. If you don't put the hyphen in, you lose a mark. Now you put another hyphen. Now we're going to go 6,6 hyphen, and we're supposed to squeeze in here dimethyl. So I just want to write it out nicely for you, so we need lots of space. So it's 5 ethyl, 6,6 hyphen, dimethyl. Okay, now let's just get rid of all of this here. Okay, make sure you always have plenty of space when you're writing it out. So it's 5 ethyl, 6,6 dimethyl, octan 3-ol. My goodness me, that is a whole mouthful.